Our next speaker is something of a rebel, I think, in the scientific community. William Happer is Professor Emeritus in the Department of Physics at Princeton University. And prior to coming to Princeton, he taught at Columbia University and served as director of the Columbia Radiation Laboratory. He has some government experience, some recent and some from about 30 years ago. He served as Director of Energy Research in the U.S. Department of Energy from 1991 to 1993, and then most recently, from 2018 to 2019, he was Deputy Assistant to the President and Senior Director for Emerging Technologies at the White House National Security Council. He told me at dinner last night that he's more convinced than ever after his most recent service that there is a deep state, and it's much worse than it was 30 years ago. He's a co-founder of the nonprofit CO2 Coalition, which seeks to educate policymakers and the public about the vital contribution made by carbon dioxide to our lives and our economy. And I just want to say, I'm also in favor of carbon dioxide. He's a co-founder of Magnetic Imaging Technologies Incorporated, which specializes in the use of laser polarized noble gases for magnetic resonance imaging. He also invented the sodium guide star, which is used in astronomical adaptive optics systems to correct for the degrading effects of atmospheric turbulence on imaging resolution. And I'm hoping he's going to tell me at least what that means. But the author of more than 200 peer-reviewed scientific papers, he's a member of a number of professional societies and associations. His
gases, and CO2 is indeed a greenhouse gas. It's not a very good greenhouse gas at today's concentration, so let me show you that. This is something I want you to remember. This is an important slide. So there's a lot of history here, and so there are two pictures here. The top picture is Max Planck, and Max Planck was the great German scientist who discovered quantum mechanics, and amazingly, quantum mechanics goes back to greenhouse gas physics, thermal radiation, just what we're talking about today, and just what climate fanatics don't understand yet, 100 years after Planck. But Planck understood it very well. And Planck was the first one who was able to show why the radiation from warm bodies has the shape it has. On this picture to the left of Planck and below is Schwarzschild, I'll have more to say about Schwarzschild in a minute, is a smooth blue curve. And what that is, again, left to right is wavelength, or the frequency in this case, of light, thermal radiation, and up is the thermal power that's going out to space. And so if there were no greenhouse gases, the radiation going to space would be that Planck curve, that blue curve there. And that would be the radiation that keeps the Earth cool. In fact, that's not what you observe if you look down from a satellite, and we have lots of measurements now. What you see is something that looks a lot like the black curve that's below, with lots of jags and wiggles in it. And that curve was first calculated by Carl Schwarzschild, whose picture is below Planck. Carl Schwarzschild was an officer in the German army in World War I, and he did some of his most creative work in the trenches on the Eastern Front, facing Russia. And he, in fact, produced one of the first analytic solutions to Einstein's general theory of relativity while he was there, on the front lines. And alas, he died before he got home, not from Russian bullets, but from an autoimmune disease, which was really tragic. But anyway, Schwarzschild was the theorist who figured out how to calculate how the real Earth works with greenhouse gases in it. It's those jagged black lines. Now, the important point here is that you notice there's also a red line on this chart. What the red line is what would happen if you double the CO2 concentration from today's level. So right in the middle of these curves, I'm sorry I don't have a laser pointer here, but you can see a gap, and that's due to CO2 absorbing radiation that would otherwise cool the Earth. If you double the amount of CO2, you don't double the size of that gap. You just go from the black curve to the red curve, and you can barely see the difference. So the message I want you to understand, which practically no one really understands, is that doubling CO2 almost doesn't make any difference. It goes from that black curve to the red curve, and on the basis of this, we're supposed to give up our liberties. We're supposed to give up the gasoline engines of our automobiles. We're supposed to accept dictatorial power by Bernie Sanders and Ocasio-Cortez because of the difference between the red and the black curve. You know, don't let anyone convince you that is a good bargain. It is a terrible bargain. The doubling actually does make a little difference. It decreases the radiation to space by about 3 watts per square meter. In comparison, the total radiation to space is about 300, so it's a 1% effect. It's actually a little less than that. And that's with no clouds. Clouds make everything even less threatening. Finally, let me point out there is a green curve. That's what happens if you take all the CO2 out of the atmosphere. No one knows how to do that, and of course we'd all die because plants die if you take all the CO2 out of the atmosphere. But what this curve is telling you is the greenhouse effect of CO2 is already saturated. That's the jargon in science. It means it's done all the greenhouse warming it can already, practically. And doubling it practically doesn't make any difference. You could quadruple it. It also practically makes no difference. So the CO2 effects are strongly, strongly saturated.
You dudes are setting a bad example.